Greetings to you, Math 151 students. This is my first video for you. You're going to see videos that I've done for other classes that work pretty well, I think, with what we're going to do. But this is the first, and welcome. I hope to meet you face to face sometime. This is kind of an introductory video. We're going to be talking about things that are probably not new to you, but let's go ahead and just go through them methodically. And that's what I want to do with every one of these videos. I want it to be something that you can say, wait a minute, I didn't quite get that. And you can stop, back up, watch it again. You can't do that in a face-to-face class. So let's just, as much as possible, avail ourselves of that very notion of backtracking, seeing it again, doing it again, and then practicing. This whole class is about practicing. We're going to be encouraging that as much as possible. I'm giving lots of homework assignments or homework in the assignments, not because I want you to suffer. Some people just really have grown up with the wrong impression about what homework should be about. I want this to be fun. I want this to be such a joyful trip, and it's going to take practice to get good at it. Just like learning a musical instrument, same thing. You're going to need to practice again and again. That's what happened to me, and it will happen to you. Okay, we're going to first of all start talking about the graph of a function and how we have two entities called x and y that work together. And let's suppose that I have this equation. Let me look at my little cheat sheet. 3x minus 4y is equal to 8. And I want to know, is the point 4, 1, does that point work? Well, I want to remind you that x always, just like in the alphabet, x comes first and then y. So here's my x coordinate, here's my y coordinate. And so to find out if this works or not, I'm going to simply take this 4 and put it in this slot here that's described by this letter x. This x is a placeholder. It's like a bucket, and I'm going to see if I put the number 4 in there and if I put the number 1 in for y, does it work? Well, 3 times 4 minus 4 times 1, there's my x value, 4, and there's my y value, 1, and don't get them mixed up, x always comes first. 3 times 4 is 12, minus 4 times 1 is 4, 12 minus 4 is 8. Yes, this point, 4, 1, is on the graph of this equation. We'll get more into that in a little bit, but graphically, it will look like this. Here's my coordinate axes. I'm going to jump ahead a little bit, but I bet you all have seen this before. I'm going to make this into slope-intercept form. I have minus 4y is equal to negative 3x plus 8, moving things around. Well, you know what? It'd just be good to remind you of what we're doing here. I know if I have a is equal to b, then for any c, a minus c is equal to b minus c. And I can also add it too. A plus c is equal to b plus c. These are tools. These are things that you should always grab from your toolbox that will always work. It's not magic what I'm doing here. It is tools that I'm providing you. And that's what I've done here. I have subtracted 3x from both sides, just like this. I have Yeah, that's what I've done here. Now I'm going to multiply through by a negative 1. And that rule is simply AC is equal to BC. In this case, I'm going to multiply by negative 1, and I'm going to get 4y is equal to 3x minus 8. And then I'm going to divide both sides by 4. That's the same as A over C is equal to B over C. I'm going to divide both sides by 4, and I get y equals 3/4 x minus 2. So my slope-intercept form is going to be, I'm going to go down to minus 2 there. That's where my y value is equal. That's where my, when I have x equal to 0, that's what my y value is. My slope is 3/4, which means it climbs up 3 for every 4 that it goes across. So there's a point there. And I said that the point 4, 1 is on this graph, and oops, missed it a little bit. But that's the point 4, 1. It is on the graph of that line. We'll do much more of this, but I just wanted to show you that for now, tools, you'll need these, and also is this x and y point, is it on this line? The next thing I want to talk about is the distance formula. I have 2 points on my coordinate axis. Let's suppose one of them is 2 minus 1. Oops. Minus 1 minus 2. X comes first. And then let's say 3, 1 here. And I want to know, what's the distance between these 2 points? Well, we have this good friend who lived long ago named Pythagoras. And he came up with the concept that if, that pen doesn't seem to work very well. Let's see if this one does. There we go. If I have this length here, which is some number, I don't know what it is. Let's call it A. And this number here, this height here, B, if I take A squared and B squared, that's going to equal the length of this, what's called the hypotenuse, C squared. I'll call that C, which is my distance. From that, we know then that that distance, C, is going to equal the square root of the difference, the sum of the 2 differences squared. This one, this length here is going to be 3 minus a minus 1. And this length here is going to be 1 minus a minus 2. 1 minus a minus 2, which if you remember from your signs, this becomes the square root of 3 minus a minus 1 is 4 squared, plus 1 minus minus 2 is 3 squared. That's the square root. So many people want to say, oh, that's 4 plus 3, which is 7. No, sirree. And it's because of this fact. The square root of a squared plus b squared is not a plus b, because I've got this plus sign in the middle of it. It does not equal a plus b. It may be something that you can reduce later, but it may not. And in this case, it's not. Because of that, you have to honor this plus sign. So this becomes 16 plus 9, 4 squared plus 3 squared, is the square root of 16 and 9 is 25. Ooh, that is a nice one. That's equal to 5. So this length here, my distance, is 5. And I get that from this distance formula, and I get this from that Pythagorean theorem. Last thing I want to talk about is the equation of a circle. And your book has kind of a formula, and I'm just going to say that's equal to x minus h quantity squared plus y minus k quantity squared is equal to your radius squared. We will, towards the end of the class, talk about this a lot more. But right now I want to tell you that h and k are the points of the center of the circle. If our circle is at the origin, h is 0 and k is 0. So it becomes simply x squared plus y squared is equal to the radius squared. Let's suppose our hk is 1, 1. So the center of my circle is there. And let's suppose my radius is equal to 3. Then my circle is going to look like something like that. And the equation is going to be x minus 1, that's my h squared, plus y minus 1 squared, that's my k, is equal to, and my radius is 3, 3 squared is 9. That's the equation of this circle. Just kind of want to touch base with section 1.1. A lot of review, I'm sure, and we'll keep going. Thanks a lot. See ya.